Hey, hello, welcome back. So we are starting a new unit. This will be Unit 5. 5.1 is Introduction to Polynomials. And a big section of 5.1 is rules of exponents, which you learned in Algebra 1. So this should be a review. So the rules of exponents are as follows. I'll go over the rule and then an example. So starting with the product rule, states that when you multiply like bases, you add the powers. So for example, if you have x squared times x to the third, that works out to be x to the fifth. You add the 2 and the 3. Second one, I call the first power rule 1. When you have a base raised to a power and that's raised to another power, you keep the base and multiply the powers. So x squared to the third power would become x to the sixth power. You multiply 2 times 3. The next one I call power rule 2. If you have more than one base together raised to a power, basically they both receive that power. Let me clean up my handwriting there. So ab to the m is a to the m, b to the m. As an example, if you have 5x squared to the third power, that would become 5 to the third power and then x squared to the third power. Of course, these will simplify. 5 to the third power is 125 if you multiply it out. And then just like the previous rule, x squared to the third power would become x to the sixth power. Next is called the quotient rule. Remember, quotient means divide, so this will look like a fraction in most cases. So a to the m divided by a to the n, the rule is you subtract the powers, a to the m minus n. So if I had x to the 8th divided by x to the 5th, that would be x to the 8 minus 5, which is 3, x to the 3. Next one is probably the easiest one on the whole page. It's called the zero exponent rule. Essentially, anything raised to the 0 power always equals 1. So if you have 5 to the 0 power, it's 1. The only exception is 0 to the 0 power. 0 to the 0 power is not 1, it's undefined. But that never really happens, so don't worry about it. Finally, we have the negative exponent rule, and I have this written twice. So, written twice, so I'll talk about them both. If you have a base raised to the negative power, it becomes 1 over that base, and then the power turns positive. Sometimes it's called the reciprocal rule, because it, in essence, flips the number upside down. So if we have 5x to the negative third, that negative third is attached to the x, so this would become 5 times 1 over x to the third. The 5 is not affected by that power, so it's just 5 times x to the negative third. And then if you simplify that, put this over 1 and multiply, you get 5 over x to the third. The second version of this negative exponent rule is 1 over a to the negative n. So this is already sort of flipped. It starts out that way. That negative exponent basically unflips it, makes it a to the positive n power. So if you have, for example, 2 over x to the negative fourth, it becomes, didn't mean to do that, 2x to the positive fourth. So those are the basic rules of exponents from Algebra 1. There's several exercises where we will practice these. Then we will get into polynomials in general. So the definition of a polynomial is, frankly, awful. It's this. So you're supposed to look at that and say, oh, okay, I know what that means. I mean, have you ever seen anything so bad for as long as you've done, math? You've got variables, powers, subscripts, you've got ellipses, dot, dot, dot. I mean, oh my gosh. So we're going to look at an actual example of a polynomial and try to make sense of it that way. So here's an example of a polynomial. 5x to the third minus 2x squared plus 7x plus 4. So what we have is x is our variable. Every variable can have a coefficient. That's a number multiplied by it. It could be positive or negative. Every variable can have power, so third power, second power. That 7x there, x technically does have a first power. If you don't see a power on a variable, you always assume it's a 1. And then it ends with a constant, so plus 4 is called a constant because there's no x next to it. So this polynomial is made up of 4 terms. 1, 2, 3, 4. Man, I've done a lot of highlighting. It is written in what we call descending order. Descending means counting down. If you look at the powers, 3, 2, 1, and then technically this would be x to the 0 power, because remember up here, anything to the 0 power is 1. So that 4 is like saying, well, it's 4 times 1, and then 1 is basically x to the 0 power. You wouldn't write it this way. That's silly. The only reason I'm explaining it is so you can see a pattern. We've got x to the third, x to the second, x to the first, x to the 0. So there is some logic behind this. It's not just random rules that some mathematicians slap together. But yeah, you normally don't write that there. And so that's called the constant term. It does not have a variable. Now, the highest power in the whole polynomial is referred to as the degree. So this is a third degree polynomial. And the coefficient of that term is the lead coefficient, because lead for being in first. It's the first thing you see when you read that polynomial. So this definition, it basically says, okay, you're going to have a coefficient, a variable, and a power, and that'll be the highest power. Plus or minus, because the next coefficient could be negative, x, and then the power counts down by 1. Plus or minus another coefficient, another variable, another power counted down. And dot, dot, dot means that pattern continues until you get a coefficient times x to the first power, and then a constant. So that definition of a polynomial, it really does mean something, but the notation is just so think or look back to this example if you need to. What we're going to do with polynomials, we're going to add and subtract them, which is combining like terms, and you've done that before. Possibly distributing negatives. Remember when you subtract, like if you had something like minus x squared plus 2, you would distribute that negative and it becomes minus x squared minus 2. So that's a thing we'll have to worry about. And then multiplying, which we've already done a bunch of. That's foiling or distributing. And there's not a lot of these problems. And then you're going to be responsible for knowing the vocabulary degree, and you're going to be responsible for knowing how to write your answers in descending order. Okay, so as usual, I'm going to do the even problems, assign the odds. You're going to need to show your work where applicable and check your answers. Don't forget to put a score on your paper. Always put your 10 out of 10 or 9 out of 10 or whatever on your paper, or write it in the comments. Okay, so the first several examples are just going to be an Algebra 1 review of these rules of exponents. And they start out easy and they get a little more complicated as we go. So this is a multiplication problem. We've got coefficients here, and we do have variables. And as long as the variables are the same, you can multiply them together. So when we multiply this, we have basically 1 n to the second. So 1 times 4 is 4, 4 times 2 is 8. And then n to the second, n to the fourth, n to the third. The rule is to add these powers together. 2 plus 4 is 6, 6 plus 3 is 9. So that works out to be 8n to the 9th power. Tell you what, I'll do another one, and then I'll scroll down and check these two at a time. The next one, number 4. So we've got multiple bases all raised to the same power. Those parentheses basically means that power applies to everything in the parentheses. So that becomes 4 to the 4th, n to the 4th, m squared to the 4th. And we can simplify this. 4 to the 4th power, grab a calculator if you need to, works out to be 256, I believe. N to the 4th, you can't simplify, it's just n to the 4th. M to the 2nd to the 4th works out to be m to the 8th. Okay, so we got a couple done here. Let me scroll down and check the answers. Oh, having trouble with my iPad. Okay, there we go. So 8n to the 9th and 256 n to the 4th, m to the 8th. So far, so good. Yes. All right, let's do this next one. Okay, number 6, we got a couple things going on. Here's what I would suggest. Let's do what's in parentheses first. Just ignore that 4th power right now. So if we do what's in parentheses first, we have 2 times 2, which is 4. P to the 2nd times p. Remember, no power means there's a power of 1. So if you add the powers, p to the 2nd, p to the 1st, that's p to the 3rd. Now, that 4 that I told you to just sort of temporarily ignore, it goes right there. So this becomes 4 to the 4th, p to the 3rd to the 4th. 4 to the 4th, again, 4 times 4 times 4 times 4 is 256. P to the 3rd to the 4th, multiply these variables, that's p to the 12th. Hopefully you recall doing these in Algebra 1 a couple years ago. I'll do number 8, and then again I'll check 2 at a time. All right, number 8 is a division problem, 3n over 3n to the third. So how do you do this? Well, first of all, 3 over 3 just cancels. 3 divided by 3 is 1. Now, one way to do this is to say, okay, I've got n on top. N to the third means I've got 3 n's on the bottom, and then when these cancel out, remember when things cancel, they're dividing. N divided by n is 1, so that leaves you with 1 over n times n, which is 1 over n squared. Oops. So that's one way to do it, but honestly, you don't want to have to do this, because if this was a 30th power instead of a third power, would you really want to write 30 n's down here? That would be pretty ridiculous. So we have the quotient rule. So I'm going to do this all over again. Well, still, the 3 divided by 3 cancels out. That gives you a 1 on top if you need it. And the rule is to subtract the powers. So this n is n to the first power. So we've got n to the first over n to the third, and you're supposed to keep the variable and subtract the powers, 1 minus 3. That 1 is like having a 1 here. And that gives us n, 1n, to the negative 2. And if you recall what I said about negative powers right here, it reciprocates or flips, becomes 1 over. So this would become 1 over n to the 2. Same answer, different way of doing it. And now sort of a third way of doing it that's the quickest, most efficient way to do it. Again, you say, okay, the 3's cancel. Then you go, okay, 1 minus 3 is negative 2. Or you can say, I'm going to subtract them the other way, 3 minus 1, and just remember to put my answer on the bottom. If you think about it, I mean, there's more n's on the bottom than there are on the top, so it makes sense that the variable would end up on the bottom. And again, the 3's that cancel, 3 divided by 3 is 1, so you put a 1 up there. And you get the same answer third time in a row. All right, let's check those and make sure I haven't messed anything up. So 256 n to the 12th, 1 over n squared. Now they're getting a little more complicated. This one here is another quotient rule. So I'm going to do it kind of like the third method that I used when I did this. So first of all, 4 divided by 3. 4 and 3 don't cancel. They don't divide out. So I'm just going to leave a 4 on top, a 3 on the bottom. Here we have a to the 4th over a to the 1st. So when I subtract those, 4 minus 1 is 3. There's more a's on top, so that tells me a to the 3 is going to go on the top of the answer. Whereas with the b's, there's more b's on the bottom than the top. So when I subtract these, 2 minus 4 is technically negative 2, but you don't want a negative exponent, because then you have to do the negative exponent rule. You just say, okay, these 2 cancel with 2 of those, and we're left with 2 on the bottom. Number 10 is, let's see, it's a whole other page. Let me check number 10 before I do number 12. And there it is. We're good. Okay. Number 12. It's on a whole different page, and there's multiple steps here. So here's what I'm going to do. I'm going to just work out the top and kind of disregard the bottom for a minute. The top is multiply. 3 times 4 is 12. Then we have y times y. Remember, those are like both y to the first. So the rule is you add the powers. 1 plus 1 is 2. And then x to the third, x to the fourth. That would become x to the 7th. So I've simplified the numerator, the top. Let me carry over the denominator. And now we can do the divide part. So what do we have here? Well, 12 divided by 4 is 3. Y to the second over y to the first. When you cancel or reduce this, you're going to get y to the first power, right? 2 minus 1 is 1. And x to the 7th over x to the second. When you reduce that, 7 minus 2 is 5, so that's x to the 5th. Now, everything that was in the bottom of this fraction did divide out, so there's nothing left there. You could put it over 1, but you don't really need to. You just call that your answer, or the answer key will probably say 3y x to the 5th, because when there's a first power, typically you don't write that down. You just drop a first power. So let me check number 12. And yeah, there we go. Okay, number 14. Okay, a lot going on here, but before I do anything, The one thing that jumps out at me is b to the first power. So remember the zero exponent rule, anything to the 0 power equals 1. So that b to the 0 power is essentially just a 1. And 1 times a to the fourth will be a to the fourth. So if you have something like this, b to the first 0 power, not first, sorry, b to the 0 power. Oops, sorry about that. Got away from me here. If you have something like this, anything to a 0 power, you can just sort of disregard it. It really doesn't mean or do anything. It just turns into a 1, and when you multiply something by 1, no big deal. Now let's focus on this. We do have a case where we've got a power on parentheses that we need to apply in the parentheses. Okay, I'm going to work downward instead of across here. It's going to line up better for me. So what I have here is 2 to that third power, and then b to the fourth to that third power, times a to the fourth, and there's no need to bring down b to the 0 because it's just a 1. Now 2 to the third power, 2 times 2 is 8. b to the fourth to the third is b to the 12th, times a to the fourth would just be a to the fourth. And that should be the answer. I'll be honest with you, I'm a little, I don't know, I've got my own little rules that I always like to follow. I like to put variables in alphabetical order. So in my opinion, oops, that's the better answer, but let's see how the answer key did it. Number 14, yeah, they did not put it in alphabetical order. Same thing for number 10. Really, I would write that 3x to the 5th y, but whatever. Okay, number 16. So we got a lot going on here. First of all, before I do anything, that's going to go away, right? Anything to the 0 power is just 1, so that turns into 4 times 1. 4 times 1, yeah. Next, can I simplify anything? The top really cannot be simplified, but the bottom, it would be okay to go ahead and multiply 4 times 2. So I have 4 times 2 is 8, v to the negative 2, u to the 3. Forgot the negative. Okay, now I'm going to do the negative exponent rule. So essentially, here's what happens most often with negative exponents. The terms with positive exponents you're not going to touch. You're just going to leave them alone for a step. So that goes there, whatever. The ones with the negative exponents, just flip them. The fraction bar is where you flip. So v to the negative fourth in the numerator flips down to the bottom and becomes v to the positive fourth. V to the negative second on the bottom flips to the top and becomes v to the positive second. So that's what that negative exponent rule, it reciprocates or flips over as like a fraction. Since there's already a fraction bar there, you just put it from the top to the bottom or the bottom to the top, whatever. Now we divide. Well, 3 and 8 won't divide, so we can just leave those as a 3 and an 8. We have u to the second over u to the third. Okay, so when we subtract these, where is the u going to go? The top or the bottom? Where are there more u's? Well, 3 is greater than 2, so there are more u's on the bottom. So 2 of these cancel out with 2 of those. It's going to leave a u on the bottom. 3 minus 2 is 1. That's why there's 1 u on the bottom. Same thing goes for the v's. There's more v's on the bottom than there are on the top, so you subtract those. 4 minus 2 is 2, so you have v to the second on the bottom. And that should be the answer, 3 over 8u v to the second. Check number 16, and there it is. Good. All right, one more of these, and then we get into the next section, and the next section is pretty darn easy. Again, we'll work in parentheses first. Do parentheses first, just like order of operations, so ignore that 3 for a minute. What do we have here? Oops. Well, if we just look at the numbers, this is like 1x to the third, so if I do the multiplication, 1 times 2 is just 2. If I do x to the third times x to the negative 1. Now you might look at that negative 1 and say, okay, I need to flip that. Well, hold on. We also have this rule that says when you multiply like bases, x times x, you need to add the powers. What's 3 plus negative 1? 3 plus negative 1 is 2. So there was no need to flip that. The negative just sort of went away. Is that going to happen with the y's? If I multiply y to the negative third times y, well, remember that has an implied power of a 1 there. So negative 3 plus 1 is y to the negative 2. So no, that power did not go away. We'll deal with that in just a second because we still do have that third power there. That third power has to apply to everything in the parentheses. So I get 2 to the third, x to the second to the third, y to the negative second to the third. A lot of steps here. 2 to the third, 2 times 2 times 2 is 8. X to the second to the third, you multiply those, that's x to the sixth. Oops, same thing here, y to the negative second to the third, you multiply those, that's y to the negative sixth. And now I can go ahead and deal with that negative exponent. And here's basically the best strategy I can give you. Draw a fraction bar. The thing with the negative exponent flips to the bottom. The other numbers, since they don't have negative exponents, stay on top. And that should be the answer to number 18. Let me scroll down and check. There it is. We're looking good. So that's it for reviewing the rules of exponents. Please do the odd problems. Moving on from here, simplify each sum, each difference, combine like terms, or simplify, and find a product. Product is multiply. So kind of a lot of exercises here, but a lot of these are going to go quickly. First of all, the parentheses. In this problem, these parentheses do absolutely nothing. They just group this together to show that it's a polynomial. It was like a unit, or it went together. Same thing for these parentheses. They just group that together. Technically, I guess you'd say you're supposed to distribute a plus sign. Well, that would give us plus 6x to the fourth. And when you take a plus times a minus, it's going to stay minus. So distributing a plus sign is really doing nothing at all. Now, we need to simplify this. That means combine like terms. So let's see. Those go together. Negative 3x to the fourth plus 6x to the fourth is 6x. No, negative 3 plus 6. Come on. 3. Duh. I'm a cotton-headed ninny-muggins. All right. Negative 3 plus 6 is 3. X to the fourth plus x to the fourth. Now here the powers do not change. You're combining like terms, the powers don't change. It's not like up here where you add the powers or multiply them or divide them depending on what rule you're doing. When you're combining like terms, powers don't change. All right, so we combined like terms there. Next, 2x to the third does not have a like term. It's positive, so I can bring down plus 2x to the third. And then last, minus 3x squared. There. Now, we're supposed to write our answer in standard position. That means I started with the highest power and worked my way down. And then I'm asking you to state the degree. So this is a fourth degree polynomial because there's a 4 there. So you don't have to write fourth with the th. Let's go ahead and write our answer, comma, and then I'll put 4 for fourth degree. Now the answer key, I threw this part in myself. It's not going to be part of the actual answer key. I'll probably go down and write that in myself. So like the comma 4, when you go to check yourself later on these, you'll see my handwriting in some of these answer key problems, or problems for the answer key. I don't know what I'm saying. Moving on. Number 22. So this is a subtraction problem. Again, this first set of parentheses here does really nothing. X to the squared, x to the second, plus 2x to the third. But with these parentheses, I do have to distribute the negative sign. That gives me negative 8 plus 4x. Remember, a negative times another negative equals a positive, so plus 4x squared. Now to do this in standard position, I'm going to focus in on the highest power first, 2x to the third. Then the next highest power, x to the second plus 4x to the second is plus 5x to the second. And then all we have left is minus 8, so there's minus 8. State the degree of the polynomial right there, third degree, so I'm going to put a 3. So that's my answer, 2x to the third power, where am I? Yep, and then so comma, third degree. Boy, I sure hope I remember to finish the answer key before I save this and post it. Okay, number 24, same basic thing. We can just rewrite the first polynomial, distribute the negative sign to the second one, negative 6x squared plus 2x to the third minus 1. Simplify it by doing the highest power first, 2x to the third. Then the next highest, plus 8x squared minus 6x squared is plus 2x squared. The next highest would be just the regular x, so minus 8x. And then the constant term is going to be 8 minus 1, which is a positive 7. And again, a third degree polynomial, you can tell that's the highest power. So number 24. Whoa, say what? That has 10x. All right, what did I do wrong, friends? What did I? Oh, I copied it down wrong. Good grief. Look at that. That's x to the third, and I wrote x to the second. So, yay Haskell, why don't you do the problem the right way? 8 minus 8x plus 8x to the third minus 6x squared plus 2x to the third, minus 1. This term goes with that term. 8 plus 2 is 10x to the third. Well, it's a good thing I checked myself. Minus 6x squared minus 8x. And then 8 minus 1 is positive 7 plus 7, and it is a third degree polynomial. So that had better be my right answer. And yeah, looks much better when you do it the right way. Number 26 is just torture. It's the same thing, but more of it. Again, you distribute a plus sign, it really doesn't do anything, so you can just drop the parentheses. But here you distribute a negative sign, it does do something. The double negative turns to a positive. All right, this is my highest power, plus 5 n to the fourth, plus 8 n to the fourth. That's 13 n to the fourth. I don't have any x to the third terms, but here's second power, negative n minus 4n. That's minus 5 n to the second. And then 1 minus 4 is negative 3. Negative 3 plus 8 is positive 5. That's the constant term, and this is a fourth degree polynomial. Number 26. Just put a fourth degree polynomial there. And I got a, uh-oh. Looks like I did something wrong because this is a plus 1 for my constant, and I have a plus 5. Am I rushing? What am I doing? All right, genius. How did I turn that minus 4 into a plus 8? I mean, I know why it's a plus. It's a plus because you have the minus minus. But that should still be a 4. So now when I add my constants, 1 minus 4 is negative 3, plus 4 is positive 1. Good grief. All right. Whatever. There we go. All right, find each product. And look, there's not much left. So this is a distributive property problem. We've done this over and over. So 42n, 6 times 3 is plus 18. And this is a first degree polynomial. The variable n, if it doesn't have a power, remember that counts as a 1. So this is a first degree polynomial. There we go. Check that off. Oh, this was a third degree polynomial. All right, and then number 30 is a FOIL problem. We've done a bunch of these. That's going to be 16x squared minus 24x plus 16x minus 24. We have like terms here that we can combine, so you get 16x squared minus 8x minus 24. This is in the proper descending order, and it is a second degree polynomial, so I'll put comma 2 for second degree. And on my answer key, I'm going to put comma 2, and there it is. Okay, so hopefully this makes sense to you. If I went too fast through any of it, just stop the video, go back, rewatch a problem or two, and contact me if you have questions. Otherwise, good luck and